Welcome to another live stream episode of This is Automation. I'm your host, Corey Dallas, and we're very happy to have you here. For those of you that tuned in live for the first Git live stream, we had some technical difficulties, so we are just rerunning the entire episode. So if it's not new to you because you watched the last one, then sorry. So hopefully we'll be good to go on technical details this time and be able to talk about Git. So Git is a version control system. It's one of the most popular version control systems out there. So we're going to talk about Git, some of the kind of basic details of Git, introduce you to the Git actions, some of the tools out there that wrap up Git into a nice GUI, and some best practices, tips, tricks, all those kind of things that you guys are interested in, and some of that specifically in the context of Automation Studio. Coming up, we have a couple more episodes scheduled. One is Anatomy of an IO Slice. So this one's going to be pretty interesting. We'll be talking about the X20 IO Slice from B&R. It seems like a pretty simple and boring subject, but there's actually a lot wrapped up in that tiny little package. So we'll talk through that, some of the interesting things that IO platform offers. And then starting next week, we will be talking about OEE. So OEE is overall equipment effectiveness. It is a buzzword, so to speak, that gets tossed around a lot, but we're going to talk about what it actually means, how to calculate it, and some of the different software tools inside of Automation Studio to help you calculate it and aggregate your data, as well as visualize it. So that'll be a good one for those of you out there that are interested in learning a little bit more about OEE and how to implement it. But back to the topic at hand today. Again, we will be talking about Git, and we are joined by a special guest. We have with us today Kyle Goins. How are you doing, Kyle?
Good. How are you, Corey?
I'm doing well. Kyle is a application engineer for B&R. He's got a background in computer engineering, so he knows a lot about version control in Automation Studio and in other platforms. So we'll consider him the resident Git expert, at least of the two of us on the episode. All right. Thanks for joining, Kyle.
Yep, happy to be here.
So we'll start with a quick introduction to version control. What is version control? Why would you even need to use version control? Then we'll talk through the specifics of Git. It can be a little complicated, a little overwhelming at first, and then best practices, tips, tricks, and then we'll actually look at it live on Kyle's computer. So he'll show us making a change in an Automation Studio project and pushing that change to the repository. So before we get too deep into all of that, let's answer the kind of overarching question of what is version control. So version control, pretty simply put, is just a system to track changes in your project. So again, we'll be talking in the context of Automation Studio, but use this on any software project, really. It's a way to track all of your changes and revisions for the different software modules within that project. There's another type of version control called distributed version control, which is actually the type that Git is. And we'll talk more about this in just a second, but the only difference really is that a distributed version control system has both a central repository and a local repository. So we'll answer the question, what is a repository, and also what do you mean by central and local? But just keep that in mind, that we're talking about a distributed version control system that's going to be used to track the changes in your project. So why did we choose to talk about Git specifically? Really, the main reason is that it's just one of the most popular version control systems out there. This is from a Stack Overflow survey from 2018. You can see the link in the bottom if you want to go fact check me. But 88% of professional developers are using Git as their version control system. An interesting note, only 4% are not using any type of version control. So the others are made up of a myriad different types of version control that we won't talk about today. But the interesting thing that I'm going to bring up, at least an anecdotal observation, is that I think these numbers are maybe skewed a little for the industrial automation industry. where we see more developers, PLC programmers, not using version control. And hopefully this gives you some of the tools that you need to start using version control if you've never done it before, or enhance the version control that you're using right now. So some context for why we're using Git. Really, it's just because it's the most popular. It's the most popular for, again, a variety of different reasons, but we're not going to talk about comparing and contrasting today. Good. So we just mentioned repository, central and local. What is a repository? A repository is just a collection of files and packages or folders associated with a given project in the revision history of each one of those. So any of the files inside of a project could have different revisions. They could have multiple people working on them, creating multiple revisions in different branches, for example. We'll talk more details on that stuff, but just know that repository is just that collection of files. So in the context of Automation Studio, that is pretty much going to be your Automation Studio project. All of the software in the logical view, all of your hardware configuration in the hardware view, all of that kind of aggregated into one repository location that you're working out of. All right. So if you've ever looked into Git before, you've probably seen something like this used to explain it. It can be pretty overwhelming, and we've even taken some of the different actions out of here just to simplify it a little bit for the purposes of today's live stream. But it is certainly a lot to take in all at once. So we're going to break down each of the components of kind of this overview of Git. The arrows that you see on the screen are what you call Git commands, and the cylinders are kind of the different working locations of Git. So there's 4 different locations there, and then the actions are kind of how you move files and such between those different locations. So I'll hand it over to Kyle now to start talking us through these different components of Git.
Yep. So first off is your workspace. So this is basically just, your local working copy of your project or your program. So, this is basically, your local version of your Automation Studio project that hasn't been, committed to any repository. So this is, kind of your in progress in development code. And then next up, we have the index, which is basically the staging area for code that's ready to be committed to your local repository. So say, you finish a feature or you fix a bug, you would put that change in your index in order to be basically committed later on. And now we have our local repository, which is the repository that is sitting on your computer. So this is a local tracking of basically each one of your commits. And this is separate from the remote repository.
Yeah, so maybe a quick point there just to reiterate. When we say local repository, that's what is living on your PC in almost every case. So it's a local copy of the repository, and it's analogous to the remote repository, which is usually sitting in some sort of like server location or cloud location. And that remote repository is basically the master. So the local is going to have all of your local changes on it, and that master repository is going to have kind of the aggregate of all of the different changes that are being made once they get pushed up to the master or remote repository. And again, this is usually living either in some sort of cloud service or on a server somewhere that can be kind of centrally located and accessed from all of the different local repositories.
Right.
Okay, so let's start talking through the actions now. So the text and the arrows would indicate a Git action. And again, those actions are just how we get between the different components of Git. So we'll start with add and kind of work our way through. We'll work our way up from the workspace to the remote repository, and then kind of back down from the remote repository to the workspace. So Kyle, can you give us a quick overview of the add action?
Yeah, so adding is pretty it's in the name. Basically what it is you're adding any changes you made in your workspace into the index or staging area of your repository. So it's basically just getting these changes ready to be committed.
Mm-hmm. Yeah, and you may see the index called like a staging area in this add command. You may see it called like stage, but it's the same as adding or the index. So those are analogous terms. Okay, so what do we do when we want to take it from our index or staging area and commit that to the local repository? I kind of just gave it away. We use a commit action. So the commit takes all of the files, the changes that are stored in that staged area, and commits them to your local repository. So when you do that, you would add, a comment of the activity that's been done. This is again, we'll talk about best practices, but this is going to be functional code, usually a feature or something that is a chunk of code that's been completed. You would push that up to your local repository so that you can track that, change and leave detailed comments that you know exactly what was changed there in the event that you need to revert back. So where do we go from there, Kyle?
So next we have push, which is basically taking the changes or features that you just committed to your local repository and pushing it to the remote repository that sits on somewhere like GitHub or something like that. So it's basically making the changes or features that you added available to all the other collaborators that are currently working from the remote repository.
Mm-hmm. Yeah, so let's say Kyle and I are working on a project. We're each going to have our own local repository, right, that we're making commits to as we continue to develop. And when we're ready to push a sufficient chunk of code into the remote repository, we would push that. And as soon as we push from our local repository to the remote repository, now everybody else on the project can see those changes and they can pull or fetch them if they want to. So again, in that example where me and Kyle are working, we would both have local repositories, push our changes up to the master or remote repository, and then that's kind of this central location where the whole project is managed. So that's how we get things from workspace kind of up into the remote repository. But what about when we want to go the other way? We just mentioned the use case where maybe I want to pull the changes from the remote repository because one of my other developers on the team has made a change that I need to get into my local workspace. So that's where this next set of commands is going to come into play. So Kyle, can you talk us through these?
Yeah, so fetching is basically just getting the changes that have been committed to the remote repository into your local repository. The key distinction with fetch, as opposed to something like pull, which we'll explain next, is that fetch does not commit the code directly to your workspace right away. It's basically just to be able to see the changes that say another collaborator made in your local repository before committing them into your workspace.
Yep, exactly. So then, yeah, the analogous command to that would be pull. So can you explain the differences there again?
Yeah, so for pulling or rebasing from the remote repository, it takes the changes that you see in the remote repository and commits them directly into your workspace. So it directly changes the code, in your workspace, in your project. While fetch, on the other hand, you can see the changes in your local repository, but it doesn't change any code in your workspace.
Mm-hmm. And how does a pull impact your local repository since it's going straight to the workspace?
So it impacts both pretty much. So a pull is basically just, in essence, it's a fetch plus, a commit directly into your workspace. It's kind of those two actions working from one command.
Mm-hmm. Okay, so last we have the checkout command. So talk us through that one.
Yep. So, checkout is a really useful feature that lets you basically get any version of the code as it moves up along in the in the commits. It lets you take out any version of your code into your workspace. So this is useful for saying going back a few commits. Say a new bug was introduced and you want to test out a previous version of the program. That's what checkout lets you do, and it changes your workspace to whichever previous commit you want to check out.
All right, good. So kind of aggregating all of those different commands and such together, That is kind of the Git framework. So these commands are usually not executed manually in command line. It is possible to do that. Usually there is some sort of GUI or interface that kind of wraps these up neatly. So we'll give a couple examples of what those can look like, some of the different ones out there in the market. We won't make a formal recommendation, leave that up to you and your specific application. But we'll also take a look at what that looks like in just a second. But before we do that, we wanted to talk through some best practices, tips and tricks when you're looking at using Git with an Automation Studio project. So I think the first one, especially for those of us that are relatively new to version control in general, not just new to Git, is how often should I be committing? So I'll open that question up to you, Kyle, and maybe you can give us some insight.
Yeah. So really, I guess what I see a lot is when people commit, they almost see it as some sort of backup tool where, they say at the end of the day, it's like, okay, I want to commit every single, basically at the end of every single day in order to have my code sitting somewhere that's not just on my, local PC. Mm-hmm. But really, that sort of functionality needs to be delegated to a backup tool. Git and committing with Git is best used in little bite-sized iterative pieces. As you finish either a new piece of functionality or a bug fix or any sort of bite-sized piece of working functional code should be committed and should be detailed in the commit itself. Pretty much just to provide a sequence of steps, right? So you have version 1.0 of your program and version 2.0 of your program. Like how did I get to version 2.0? So you basically want to see sets of commits that detail every chunk, every step of the way from point A to point B.
Yep. Yeah, and I think an important distinction that we kind of hinted at earlier is you should never be committing non-functional code. For example, if you try to build your Automation Studio project and you get a bunch of compiler errors, you probably shouldn't make that commit because then you're going to have a revision of software inside of your version control system that is not functional. So if you need to revert back, you may start running into issues. So again, I think the important thing is here, how often do you commit? It's not really so much time based as it is functionality based. When do you get a functional chunk of code complete, you want to go ahead and push that up. So that if you need to go back from there, you can. And it also helps you kind of discreetly break up your project into, kind of these bite-sized chunks, I think was kind of the anecdote that we were using. On a typical project, Kyle, how often would you say that is, like on average? Not saying that you should commit every, X days or X hours, but what would you say is like normal?
Yeah. Well, usually when when I'm going full 8 hours a day on a project, right? Like I'm going through. Usually I do about 4 to 5 commits a day. I would say this is like full time working and developing on a project. That's probably the average rate that I go at. But really it's so situational that it's kind of hard to nail down a specific number.
Yep. Yeah, that's fair. Again, not a hard requirement to commit 4 times a day, right? It depends on what you're working on, the scope of what you're working on, how long it's going to take you to complete, again, a meaningful chunk. So I think anywhere between like 1 and 5 times a day is perfectly reasonable.
Right.
All right. So branches is a topic that we didn't really talk about in our overview of Git, but all of those different actions can create branches, right? So it is kind of the core function of Git. What makes Git really powerful is the capability to branch. So just a quick explanation of branches, and then I'll turn it over to Kyle to explain some of the different use cases for when you might use a branch. Let's look at the image that we have on the screen here. So there's a blue line going through the middle, a green line on the bottom, and a yellowish line on top. So we'll call that blue line through the middle. That can be our master. So that's our master branch. So you can see that that first node there on the left-hand side where it says A 1.0 and B 1.0, that would be our initial commit. So kind of the first version of our software, it's got two files in it, file A and file B. Both of them are version 1.0 because it's our first commit. So now let's say I want to make a change to file A. So instead of making that change inside of the master branch, what I can do is actually create a branch for, let's say, this feature change to add some feature to file A and commit that as version 1.0.1. Once I, again, commits some meaningful bite-sized chunk. And then I need one more commit to finish out that change. So that's the second green dot on the bottom. There'll be file A version 1.1. So now I'm ready to put that back into the main, that main branch, that master branch. So when we see that the furthest right green dot, A 1.1, merging back in, that's exactly what we call a merge. So you're merging that branch into the main branch. So once we do that, now you can see that we have a commit a node at that location where file A has been updated to version 1.1. So kind of the interesting distinction here is that we start on our master branch with A at 1.0, and the next time we see A, it's at 1.1. All of the other changes, those kind of like minor changes, are happening in a branch, and then we push it back in. So this is a nice way to organize your repository. So you can see the same thing when we branch off to do a feature change on file B. In this case, we just have one commit, and then we merge it back in. So at the end on the far right-hand side, it's a little bit cut off. I'll move my image there so you can see we have at the end file A and file B both updated to version 1.1 after merging in both of the branches. So that's pretty much how branches work. The ways that we use them, though, I think is kind of the key point here. So Kyle, can you maybe leveraging this example or leveraging some of your own examples, what are some of the ways that we can use branches inside of our repository?
Yeah, so pretty much the key, or I guess the main reason to use branches is to keep the blue line in the center, like the master branch, completely clean, basically, right? Anyone should be able to go to any part of the master branch, pull code, and basically, have it be, fully functioning and fully complete for that revision. So, basically what branches should be used for is, anytime you want a new feature, anytime you're working on a bug fix, that should be, put into a new branch so that, each commit, while each commit may not, break the compiler, it certainly isn't, complete. Yeah, exactly. It's not complete. And so basically you want to take all of those commits and put them into a branch so that once that feature or bug fix is complete, then you can merge it back into the master branch so someone can pull the completed feature or, the fixed version of the code.
Yeah, and I think what you said about keeping the master clean was kind of the key point there for me anyway, is yeah, you always want that master to be fully functional code. You don't want a halfway implemented feature in your main branch, right? That main master branch should always be perfectly clean, perfectly functional, like a full revision of any software. So you want to take those changes outside of that master branch into its own branch. So, all right. So before we can start creating branches, we need to know which files do we even commit. So what we're looking at on the screen here is an Automation Studio project. So if you've never opened up your file explorer and navigated to the location of your project, this is what it looks like. So there's 5 main different folders there: binaries, diagnosis, logical, physical, temp, and then a few different files, these .set files and the .apj files. So Kyle, can you tell us what we should be aware of as far as which of these we can ignore and which of these we can commit and why?
Yep. So really, the 3 highlighted parts of the file structure of an Automation Studio project, those 3 folders / files are really the only ones you should commit. So just going down, the logical folder, holds all of the code that you would write. So any, structured text, task, or anything like that. That would be included in the logical folder, as well as, any, say a map view or VC4 visualization would also be included in that. So that's crucial to the project. In the physical folder, you have, things like your hardware configuration, In the case of certain map components, you have other necessary files that contain important parameters. You have your OPC UA map in there for which variables are activated for an OPC UA server. So those are really important in the project, and that's included in the physical. And then the last one is the just general project file, which starts up the Automation Studio project and has key information such as the version of Automation Studio and things like that. As far as the other folders, those are basically folders that contain dynamically created information. So, for example, in the binaries folder, every time you build or transfer, new binaries for your PLC are created in that folder. Same with the diagnosis and temp folder, where the diagnosis has dynamically created trends, and the temp folder, say if you start a simulation within Automation Studio, that contains specific files for that. So pretty much the key distinction is anything that you could basically replicate yourself in your local workspace, whether it be a binary or some sort of trend data or simulation data, that shouldn't be cluttering up your remote repository. And that could also cause errors as well, because binaries aren't stored in plain text, and so you don't want to be overwriting each other's binaries really, across everyone who's working from the remote repository.
Yeah, exactly. So you just want to keep the files and folders that are necessary for the project. And like Kyle is saying, those binary files, the diagnosis files, the temp files, the .set, those are all automatically generated within your instance of Automation Studio. So there's no reason to keep those in the repository. Again, with the intention of keeping it as clean as possible, avoiding unnecessary merge conflicts. Your diagnosis folder is going to be different than another developer. There's no reason to try to even merge those. It's just going to cause headaches inside of the repository, and there's no value, because all of the core software functionality of the project is going to be held in the logical, the physical, and the APJ file. So that's really all you need inside of your version control system.
Right.
Alrighty. So those are things that we should do, I think. But what about things that we should not do? I know in the context of Automation Studio, it is pretty nice, because you mentioned this kind of in passing, but a lot of the files, most of the files inside of Automation Studio are plain text readable, which
Right.
is very compliant with version control, makes merging, resolving conflicts really easy. But there is at least one exception that I think we want to bring up. So can you talk us through that, Kyle?
Yeah. So, like you were saying, most things are either in XML or, plain text, things that play well with version control, but Visual Components 4 in particular contains, packages within its structure that just do not play nicely with multiple people contributing to it on the same repository. So really with VC4, you should, whenever someone works on a VC4 application, it should really be its own branch, and only one developer should really be working on it throughout the project.
Mm-hmm. Yeah, exactly. So yeah, I guess to clarify, it's not that you can't use VC4 with a version control system. It's just that you want to limit development to just one person at a time, to make sure that everything can be merged cleanly. And hopefully everybody out there is looking at using MapView instead of VC4 now, but there are certainly a lot of new applications even that are still using VC4. So just something to be aware of. Okay. What about the different tools and solutions? So when we showed the Git commands and kind of the Git structure, there are like command line interfaces to execute those commands that are not very user friendly for the average person out there anyway. Certainly the average user doesn't need that, and it's a little more complicated than probably what you want. So the good news is there are lots of tools out there, these GUIs, graphical user interfaces, that kind of wrap up all of those commands and put them in kind of a nice like Windows application. So probably the most common ones I think are listed here on the screen. There are tons and tons of others. We're not particularly endorsing any one of these or recommending you use them. Just know that there are many out there, and we recommend you kind of look to see what's best for your application, and then move forward with that one. So the ones that we have here on the screen are SourceTree, TortoiseGit, and GitHub Desktop. Again, just a short sample. When we bump over to Kyle's screen in just a moment, we'll be looking at SourceTree. So if you like the way that looks, then feel free to use that as well, but just know that there are other tools out there. All right. Well, I think we've spoken enough and given enough background that we're probably ready to start looking at some Automation Studio and some Git in action. So we'll turn it over to Kyle's screen, and he can talk us through what he's going to do and then show us what this looks like live.
All right, sweet. Yeah, so basically what y'all are looking at right now is just a test project within Automation Studio. And so what we'll do is we'll add a task and then basically see how that interacts with Git and SourceTree. So first, I'm just going to drag over just a standard structured text program into here. And, I can name it, I'll just name it test, for example, and I'll save it. Now, usually, at this point, before you would commit anything, you would build and transfer and, just make sure that, your PLC doesn't go into service mode or, make sure that everything's functioning. But, I think, our focus is on Git, so we'll just skip the build part of it and just go straight into SourceTree.
Yeah, and
sorry,
just really good point is that you would never want to like make a change and then immediately put it into your local repository. You want to build it, you want to test it, make sure it's functional, and then you would move forward from there.
Yeah, exactly. So now we have our test task, in our project. And so now let's go over to SourceTree and see how that looks. This is SourceTree. At the top here, we have our, various commands that we went over previously with, commit, pull, push, fetch, as well as some other more in-depth features that we didn't go over in depth, such as branching and merging. Down here is basically the view of all the commits that have happened on both the local and master repository or the remote repository. So this is basically just a history of changes in your repository. So in order to see, I guess, the changes that we made, we'll go over to file status from our workspace. And so this is basically what we saw with the index. This is the index part of basically the Git workflow. So what we have is we have our unstaged files down here, and this just contains all the changes that were made to the project. And so basically, I guess what I usually do when going through this is looking through the files one by one, just to see what changes were made, and whether or not everything looks basically correct before staging and then committing. So when I click on a file, it shows basically what lines were changed over in this pane of the program. And so we can see here that this green highlighted line with a plus sign next to it was was the test task being added into the packages of the project. We can go further down and see that same task was also added into cyclic 4, looking in our CPU software view in the physical folder. Now looking further down, we can see all of our packages added into the logical view. So we can see the cyclic, the exit program, as well as just the variables and types. And so these are just the basic files that are added whenever you drag in a structured test task. So now that I've kind of seen all these, and I'm thinking, okay, I'm ready to move to the next step. I'm just gonna click Stage All, and this gets it ready to commit. So all of our files are now staged up here. And so, everything looks good to me. So I'm going to move down to the bottom here. and get ready to commit. So right here is basically where you type in your comment to commit. And so, like we said before, you want it to be, pretty descriptive about what you're actually doing within the program, so that, when anyone's going back and looking at previous commits, they can tell basically just at a glance what each commit contains without having to do something like check it out or, just delve deep within whatever changes were made. So right now I'm just going to do added test task. Okay, and that looks good. And then I will press commit down here. And so this will commit these changes to our local repository. These have not pushed to the remote repository yet, and we'll be able to see that going back to our basically view here once it loads. So basically what we can see right now is master is our local repository, while origin master is the remote repository. And we can see that our changes that we just made were added into our view here. And it's also one commit ahead of the remote repository. So basically the next step into this, once we decided, okay, I'm ready to push these changes, this looks good to me, we will go up here to the top and press push. And so this is going to take the changes from our local repository and push them to the remote repository so other people can then basically see them, fetch those changes, and merge those changes within their own workspace. So we're committing to the remote master branch, and we will click push. And then once it pushes, we should be able to see the two repositories, so the local and the remote repositories line up correctly. Mm-hmm. So it's receiving. All right, so it's completed. So once the view reloads, we can see now that that both of our branches are basically in sync. So our local repository and our remote repository are both completely up to date with each other. And next off, we will look at basically what it looks like to check out a previous version. So, even just scrolling down in a few of these test commits I previously made earlier last week, you can kind of see various changes that were made to it. So, say, for example, that test task, someone decided it wasn't needed in the program, or we wanted to go to a version without the test task to do some testing, we would basically just click on one of these previous commits, right click, and click checkout. Now, first off, really what you should do is you should, before you check out, you should close your Automation Studio project. Whenever you check out, basically all the code is, it changes the code in your workspace. And, instead of having to reload everything dynamically within Automation Studio, say if you check out like really far back in your commit history, that could, potentially mess some things up. So we will close our Automation Studio project, and then we will check out this commit. Click OK. And so this basically switches our working copy to this test2 commit. So we should see that updated here, where we see, I guess the head of our workspace is in test2. And now we will reopen the Automation Studio project. And what we should be able to see is now the test task that we previously added at the beginning of this demonstration should be gone. So we'll wait on Automation Studio to open up the project. And we should see that we checked out an earlier version.
Yeah, so I guess while that's loading, I think just kind of a quick summary of what we just saw. So we looked at how making a change inside of Automation Studio, what that looks like in Git. So you can see where changes were made in files, where new files were added. And then what you did is you staged those files to then commit to your local repository. So that's where we made sure we did really detailed descriptions, so we knew exactly what was happening. and then from there you push that to the remote repository. So then it updated the master. So that's kind of like a typical workflow for how you would continue to work through your Automation Studio project to make sure you're keeping version control up to date. And then what we're looking at now is maybe the use case where there's some error that you need to work on, a bug or something that you want to revert back, or like Kyle said, for some reason that task isn't needed anymore. There could be tons and tons of reasons for wanting to go back to a different version, but using the checkout action, we can pull that directly from the repository. And now I think we can look and see.
Yep. So really, it's pretty evident here that our task that we previously added is not there anymore, and so we can use this previous version that we checked out for testing, or if we wanted to, for example, create a branch going from this version of the code, we can do that as well. So overall, checkout is a really useful feature for things like this, because usually, in a case where, say, you don't have version control, going back in versions of the software can be extremely difficult, and then time consuming to try to keep track, mentally of everything you've changed. So this is, really, a good action that Git has to offer.
Yeah, especially when you have software with a lot of like interdependencies for the different files, it can become not as easy as just deleting something to remove it, right? So being able to actually just go back to again, known working functioning version of the software can be really, really helpful and save a lot of headaches.
Yes.
All right, so I think that was a really good summary. Hopefully that was useful for those of you out there that are kind of new to this, or at least new to it in the context of Automation Studio. Again, what we talked about today was Git as a high level. What does the workflow look like? We talked about some of the best practices, so keep those in mind for sure. And then we looked at live how to make a change in Automation Studio, then commit that and push it, and then also how to check something out if we ever wanted to revert back. Kyle, do you have any closing thoughts on version control or your experience with version control?
Yeah, I mean, version control has been, just absolutely amazing for my time as a developer. I guess before I really knew how to learn version control, I was emailing zip files back and forth and, things like that. And, that becomes really cumbersome really quickly. I would go as far to say that, version control is, pretty necessary if you're working on any sort of code collaboratively with another person. And even if you're just working on code by yourself as a single person, it's useful to be able to see each individual change that you've made, those being able to see that all in a view, and being able to go back to a previous version and branch and all the tools that Git offers, is pretty crucial in a software development environment.
Yeah, it's certainly a lot cleaner than the old school method of a giant chunk of folders that's rev 1.0.1, rev 1.0.2, and you never know what's changed between those. It's duplicates of a bunch of files that didn't even change, and you can't even really centrally manage that in a clean way, as multiple people are making different changes. So yeah, I think your point, Kyle, that version control is really pretty necessary for any modern software project. So if you're not using version control now, I would strongly recommend that you give Git a try. If Git's not right for you, that's fine. There are others out there, and Automation Studio plays very nice with pretty much all of them, again, because of the way the file structure works. But would definitely recommend it and see how it can change your workflow, because it can make a really big difference. Good. Well, thank you, Kyle, for joining us. That was a great demonstration and really good tidbits of knowledge that you shared with us. So thanks for taking some time.
Good deal. Thanks for having me, Corey.
All right. We have coming up, just as a reminder, a couple more episodes. One is going to be about X20IO. So we'll be talking about some of the different fun things about B&R's kind of flagship IO platform. There's more than meets the eye on X20, so make sure you tune into that one. That'll be good. And then again, we have implementing OEE in your machine. So for those of you that are interested in collecting data on your machine, aggregating that to get kind of an overall picture of the health and effectiveness of your machine, this will be a good episode where we dive into some of the Automation Studio tools to do that, and also how to visualize that. So looking forward to talking through those. And just as a reminder, for those of you that have not yet subscribed to the channel, please make sure you do that. You can just hit the subscribe button, and we'll post all of the live streams that we have coming up on the channel. So you can go and set notifications so you get a reminder anytime we go live, and then you won't miss any of them. But as always, all of the recordings will be on the channel as well. So if there are episodes that you haven't seen yet that you think may be useful, you can always go back and watch those. We appreciate all the shares, comments, likes. They mean a lot. We appreciate it. So keep watching, keep engaging with us. If you need to get in touch with us, you can do that through YouTube, LinkedIn, however is best for you. So there's ways to do that in the description below. We look forward to continuing to engage with you guys and bring new, hopefully relevant content about automation and about B&R and about Automation Studio. So we'll look forward to joining you on future episodes of This is Automation. Thanks for joining.